Alright, in this lesson we're going to learn about classifying triangles according to the lengths of their sides and the measures of their angles. So we're talking about isosceles triangles, equilateral, scalene, also obtuse triangles, acute triangles, and right triangles. So classification. In addition to that, we're going to talk about the Pythagorean theorem, which is that the leg squared plus leg squared equals the hypotenuse squared in a right triangle. And of course, you will often see that written as a squared plus b squared equals c squared. So you can classify a triangle according to the lengths of their sides. For example, if all three sides are equal, the triangle is called equilateral. You can hear the prefix equa, meaning equal, and lateral, referring to sides. So equilateral means equal-sided. For example, if this triangle had lengths 5, 5, and 5, this would be an equilateral triangle. An isosceles triangle has two equal sides, at least two equal sides. So say if this was 5, 5, and 3. This would be an isosceles triangle because it has two sides that are equal. Now, I should point out to you that all equilateral triangles are also isosceles because they do have two equal sides. Okay? So you don't have to have two sides the same and one side different to be isosceles. If all three sides are the same, you still have two sides that are the same. So an equilateral triangle is equilateral and isosceles at the same time. A scalene triangle has no sides that are the same. So for example, if this side were length 5 and this was 6 and this was 7, that would make this a scalene triangle with no sides the same. Sometimes we show how these sides compare to each other with markings. So if this is an equilateral triangle, we might show it by marking all three sides the same like this. That would show this was an equilateral triangle because they all have one mark. Or I could do it this way. Okay, again, that would mean this was equilateral. Because they all have two marks, that would mean that all three of these sides are congruent. They have the same length. So if I wanted to show that this is isosceles with markings, I could show it by marking these two sides the same, okay, both with a double mark, for example, and I'd mark this one with something different. Okay, so you could tell it's isosceles without actually using numbers. So if I wanted to show that this was scalene, I would mark each one of these sides with a different number of marks to show that I'm looking at three different side lengths. So maybe, for example, this could be marked with a single, this could be a double, this could be a triple. And that would mean that all three of these are different, and that would show that this is scalene. Another way that we can classify triangles is, wait, did I go the wrong way? Yeah. We can talk about their angles, okay? An acute angle is an angle that is less than 90 degrees. Alright, of course a 90-degree angle is what you're looking at. When you're looking at a square, you have four 90-degree angles. They often show a 90-degree angle by putting a little box, alright? But each one of these are 90 degrees. Okay? So that's what a 90-degree angle looks like. Now any angle that's less than 90 degrees is going to be an acute angle. So this is a right angle, alright, 90 degrees. You can see this could be part of a square. And this would be an acute angle less than 90 degrees. And of course an obtuse angle is what I'd get if I took this and I stretched it open wider. So this would be an obtuse angle. Okay, so as far as the angles go, a right angle is a 90-degree angle. An obtuse angle is an angle that is bigger than 90 degrees, like let's say 110, and an acute angle is one that is less than 90 degrees. Alright, so let's say this one was 30 degrees. Now, as far as triangles go, an acute triangle is a triangle that has all three angles acute angles. So for this example, 80 degrees, 60 degrees, 40 degrees, that is an acute triangle because all three of the angles are acute angles, less than 90 degrees. By the way, the sum of the angles in a triangle should always add up to 180. Okay? So 60 plus 40, that's 100, plus 80, that's 180 degrees total. Okay? That should always be the case. Alright, anyway, an obtuse triangle has one obtuse angle. You can't have more than one obtuse angle because that would be more than 180 degrees. So an obtuse triangle is going to have one obtuse angle, one angle that is bigger than 90 degrees. And a right triangle has one right angle, one 90-degree angle. And they will also they will often show that 90-degree angle. Instead of writing 90 degrees, they will often put a box there to show that that is a right angle, that is a 90-degree angle. Okay, so acute triangle, three acute angles. Obtuse triangle, one obtuse angle, bigger than 90. Right triangle, 90 degrees. So when we look at this image, this triangle right here could be described as isosceles. Presumably these two sides are the same. But it is also, would we say this is acute or obtuse, or is this a right triangle? Well, I'm looking at this angle right here. Does this seem to be bigger than 90 degrees or less than 90 degrees, or does it look like a 90-degree angle? One thing I encourage you to do is use the corner of another piece of paper, because you know the corner of your paper is going to be 90 degrees. So you can rotate your paper around and put it right next to the angle that you're interested in, and then it's easy to tell if it's 90 degrees or bigger or less. So for example, I can now easily see that this angle is bigger than 90 degrees because it's so much broader than my my square here. So I'll save that for later. So this is an obtuse angle, which makes this an obtuse triangle. Okay, now let's see, what about this one over here? Now they've already said it's acute because all three of these angles are less than 90 degrees. So now we have to decide, is it equilateral, is it isosceles, or is it scalene? And it looks like perhaps all three of these sides are equal. Alright, let's see. Okay, so looking at this piece right here, okay, that's how long that is. And if I take this and I just rotate it, okay, that seems to be the same length right there. And if I rotate it again, alright, all three of these sides are equal. So this is equilateral. Equilateral and acute. Okay, and let's see what's next. How about this one down here? They're calling this obtuse, alright, because this angle right here is greater than 90 degrees. But what else? Is it equilateral? Is it isosceles? Or is it scalene? Well, to me it seems that the three sides are all three different lengths. Alright, none of these look the same to me, so that would make this scalene. Alright, what about this one? Alright, they're calling it isosceles, which means that two of the sides must be the same. Okay, let me just mark this so we can focus. So isosceles, so see how these two sides are the same? That's why it's isosceles, and this side is different. But that still leaves the angles. Is it an acute triangle, a right triangle, or an obtuse triangle? It is going to be an acute triangle because all three of these angles are less than 90 degrees. Let's see, what about this one right here? Scalene, alright? They're calling it scalene because all three of the sides have different lengths. Okay, this, and this. None of those are the same. But is this an acute triangle or a right triangle or an obtuse triangle? Well, it looks like an acute triangle to me. Alright, I don't see, none of these angles are bigger than or equal to 90 degrees. Alright, and again, if you're not sure, you can use the corner of your paper, a different paper, to test. And so I can see that this angle is less than 90 degrees because it fits inside my square. This one over here is obviously less than 90 degrees. And this one, okay, again, because of the way it fits inside my square, all of these are less than 90 degrees. And you can do a similar test using the corner of any paper. Okay, what about this one? They're calling it a right triangle because clearly this is a 90-degree angle right there. Okay, so that makes this a right triangle. But what about the sides? Is it equilateral, isosceles, or scalene? It is isosceles because these two sides are equal. Alright, this side is different, but these two are equal, so that makes this isosceles. Okay? And what about this last one? They're calling it scalene because presumably all three sides have a different length. Okay, so we have this, and then this, and then this. They're all different. That's why they call it scalene. But is this a right triangle, or is it an obtuse triangle, or is it an acute triangle? Got to talk about those angles. Well, this is a right triangle because this is a 90-degree angle right here. So that makes this a right triangle. Okay? Alright, let's look at these problems here on the next page. When you look at a triangle, well, obviously you can tell from problem number 1 what the shortest sides are and the longest sides because the sides have numbers. So the shortest side is side PQ. Okay, the longest side is PR. Okay, and we can know because it has a 6 and a 10 right there. So if I wanted to classify this by the sides, all three are different, so that makes this scalene. Okay, now here's something new. Let me just zoom in for a second here. The smallest angle will be across from the smallest side. Okay, so since this is the smallest side, then this is going to be the smallest angle. Okay, so when they ask for the smallest angle, I'm going to say angle R. Alright, now the largest angle will be across from the largest side. Alright, so the largest side is 10. Okay, so that means this is going to be the largest angle. Guess I should mark it different. Okay, so angle Q is going to be the largest angle. So angle Q. Classify by angles. It's hard to tell. It looks like this might be a 90-degree angle. So I'm going to check it with a square. It's hard to get it just right, but I feel like it's close enough for me to see that this is a 90-degree angle, even though I can't quite just nail it. That's pretty good. Yep, my square fits perfectly in there, so that makes this a 90-degree angle. And I encourage you to do the same thing when you're checking, but you could use the corner of a paper to test. So this is a 90-degree angle, so that makes this a right triangle. In fact, I think I'll put the little box here. Okay, so classify by angles, right triangle. Okay, what about number 2? First of all, let's figure out what this other angle is. All of these angles should add up to 180. So if I start with 180 and subtract, I should end up with this. So if I do 180 degrees, because that's got to be the total, and I do minus 71 and minus 42, whatever's left over should be angle A. Okay, so if I start off with 180, and then I do minus 71 minus 42. Notice I don't have to hit enter in between. Okay, I can just put it all in at once. 180 minus 71 minus 42. And I can just hit enter. So I get 67. Okay, so this must be 67 degrees. Okay, now the biggest side will be across from the largest angle. So the largest angle is 71. So that will be across from the largest side. So AB, okay, side AB has got to be the biggest side. Okay, is that what they ask us first? Alright, I guess first they're asking us for the shortest side. Okay, so the shortest side will be across from the shortest angle. I'm sorry, the smallest angle. So this is the smallest angle, so that means the smallest side will be side AC. Okay, and that's what they're asking us for here, smallest side. The longest side, like I said, is going to be AB. Okay, now we're supposed to classify by the angles here. This is acute since all of these are less than 90 degrees. I'm sorry, we're supposed to classify by the sides first here. So none of these sides are the same. Okay, since none of the angles are the same, then none of the sides are the same. So this is also scalene. Okay, now we want the smallest angle, obviously, is angle B. The largest angle is angle C. And this is an acute triangle because all angles are less than 90 degrees. Okay? Alright. I'm going to stop this video here because it's getting a bit long, and we'll pick up the rest of the lesson with the Pythagorean theorem.